Today's tutorial on the calculator is how to create scatter plots with the calculator and then using the same information how to find the regression line. We're going to be doing two instances, one in this tutorial and one in the next tutorial. This tutorial is going to focus on linear scatter plots and linear regression lines. The second tutorial in this series today will be working with quadratic scatter plots and quadratic regression lines. Later on in Chapter 5, where I'll be doing it with cubic scatter plots and cubic regression lines. But the steps will pretty much be about the same with a few different keys. To start with, we're going to use this information on my paper to generate a scatter plot that is linear in nature, and then also use this information to create a regression line for that particular information. If you look on my paper, I have a price column and a demand column. The price column would be my independent variable. My demand column would be my dependent variable. We're going to determine if there's some type of relationship between price and demand. We first do this by creating a graph or a scatter plot of the information to give us an estimate of what the graph might look like. To do so, we do the following steps. First step is to input the information into the calculator. To do that, we hit the Stat button. Now when I hit the Stat button, you'll see menus at the top: Edit, Calc, and Test. Notice as I move the arrow across each of the tabs, the menu changes. We want to start by selecting the Edit menu and number 1 for Edit. Now I already have information in here from previously, so I first want to clear this information out and put the new information in. You may not have this information in your calculator initially, so you may not have to do the first set of steps. To clear out any information you might have, what you want to do is arrow up and highlight starting column L1, the whole column. Hit your clear button. Arrow down. Notice it clears out that entire column. You do the same thing for L2. You arrow over, arrow up and highlight the L2 column, hit the clear button, hit the down arrow, it clears out the information. This is what your calculator should look like with nothing in it to begin with. To input the information, L1 is your in this case is going to be our price column or independent variable column. L2 is going to be our demand column or dependent variable column. So right now I'm in L1. I simply enter each of these pieces of information followed by the enter key, one piece at a time. Notice I enter 20 and hit enter and move down to the next row. Hit 22, enter, 23, enter, 23, enter, 27, enter, 29, enter, and 30, enter. That completes the L1 column. Notice it gives me a count. So right now I'm at line 8, which means there's 7 items. Right arrow over to L2. We're going to enter the demand column into L2, starting with 60. Then hit enter, 57, enter, 56, enter, 53, enter, 52, enter, 49, enter, and 44, enter. Checkpoint 1, you want to make sure that both your L1 and L2 columns match. Otherwise, you'll get an error. To generate the scatter plot, we got to turn the scatter plot feature on in the calculator. To do that, we hit second stat plot, which is above the Y equals key. You should get a dialog menu. Plot 1, plot 2, plot 3, and plots off. Generally speaking, all the plots are turned off. We want to turn plot 1 on. So we highlight plot 1, which is already highlighted, hit enter. We get a setup menu. The first toggle is on off. It's currently off, but the on is blinking. Hit enter so the off goes to the on. You can arrow down, change each of these. The type tells you the type of scatter plot. We're going to select this default type, which is just dots. But in here, you can do things like line graphs, bar graphs. If you get into statistics, they're called box plots, but that's a stats class. XList tells us my independent variable. L1, that's the L1 column. Don't have to do anything to that. YList is your dependent variable column, which is L2. Mark tells you what you want, the points are marked with, either like a square, a plus, or a dot. I'm going to take the open square. To generate the scatter plot, all we got to do is hit the zoom key and 9. Notice it generates if you want to say, a plot of all the points. No lines yet, just the plot. That's the scatter plot. Looking at this information, okay, we can't exactly tell what the relationship is, but generally speaking, you can see as the independent variable increases, the dependent variable decreases because it's going downward. So all the scatter plot does tells you if there's a linear type of relation. Later on we'll use it to see if there's a quadratic type of relation or a cubic type of relation based on what the general plot looks like. To generate the regression line for this, we still use the same data. We entered it once, so we don't have to enter it again. You hit the stat key again, arrow over to the calc menu. Arrow down to number 4. It says LINREGAX plus B. That stands for linear regression of the form AX plus B, which is the slope-intercept form. Hit enter 2 times. Okay, it gives you y equals ax plus b, which is the standard form of a linear equation. It gives me my a value, my b value, and right now I have a special feature turned on called the correlation coefficient. Correlation coefficient is r. If r is close to 1 or negative 1, that means there is a positive correlation between the data. If r is close to 0, okay, that means there's hardly any relationship between the data. Notice my r value here is minus 0.94. The minus comes from the fact it's decreasing in nature. If it was increasing in nature, it would be positive. So my equation for this particular set of data would be y equals a is minus 1 point, I'm going to round it, 1.34, x, b is 86, round it, 86.2. This is my equation of the line for this data. Now, interestingly enough, if you want to plot this on top of that scatter plot, you can do so. All you got to do is use what we used before, hit your y equals button, and you got to make sure your plot's still turned on, which it is. We didn't do anything with it. Put this equation in, minus 1.34x plus 86.2, hit graph, and you kind of see that the graph estimates is the average of all the dots. This concludes my tutorial on linear scatter plots and linear regression.